OLTP concepts. Everything starts here. According to the introduced architecture, our entry point is data of the OLTP nature. To make the work easier, assume a hypothetical organization that collects daily data through its SQL server, or any other database management system similar to Oracle. These data have been stored in this place over time, and the data may not even be in one place and be scattered at various points, because of the type of the business as mentioned before. Now, some analyses are gonna be conducted on these data, based on which better decisions are to be made. So here, we need to make ourselves a little familiar with these concepts, to the point of knowing that database, table, and T-SQL language is just to get acquainted with them. Because this is our point of entry. We gotta have some level of familiarity with these concepts. So let's get familiar with these concepts as much as we need. If you have worked with relational databases and be familiar with the concept of the table, you know that a table is made up of several rows and columns. The data will be saved in this table in the form of rows and columns. That is, the column will be the names of our fields, such as first name, last name, contact number, and so on. And the columns are completed for each individual, making a total of 1 row for each person. Now the other rows are completed for other people in the same way, so that the data on each person forms another row. For instance, we have a database called University in this figure. Inside this database, we have 3 tables called Professor, Course, and Student. Now at the bottom, this student table is made up of the 4 fields of student no, name, surname, and ID card no. And for each field, we have entered some values, and the combination of these values make up a row or a column together. So when we complete all the fields, we are in fact completing the information on one person, the sum of which becomes a record. This is the world of the relational database. Almost everything is defined and recorded within this form, and each will be explained for you separately and through examples in the following for you. Database. Suppose you want to record the data on a specific company somewhere. You will definitely say that you should design and implement a database for this system in the beginning. Why? Because you know that a database is similar to a box containing the personal items of each individual inside it. This box prevents these items from being mixed up with other people's items. For instance, all the data on the online shop X is placed in database X, and all the data on the online shop Y is placed in database Y. Table. What is the next step you take? Now you should put the relevant items inside the box. This means we design some tables for the hypothetical online shop, and each table has been considered for several needs. For example, consider the example of shop. This shop needs to record the information of the customers. If it works as a chain store, it also needs to have the information of each store recorded, so the tables are designed based on their needs. Of course, we are bearing in mind that we'd already created a database box, and now we must put these tables, personal items associated with each shop, inside the database. So up to here, we have a database, and inside this database, we have several tables in charge of recording the information of this specific shop. Each table is responsible for recording certain information. Fields. It is probably needless to say that these tables have some fields, and the fields store certain information on each of the customers. For example, there are fields such as first name, surname, and so on in the customer field. This section is called by various names such as fields, traits, and features. Record. Now, given what was mentioned earlier, we figured that the information on customers, goods, and stores must be recorded in the table. Each portion of information has some features. For instance, features such as first name and surname are two individual features for customers. Now, the sum of the values in these features makes up a row, and each row is defined for one customer, which is a record in professional relational database terms. T-SQL. Now that the database and the respective table are made, we must perform some operations on them, such as storing some new data in these tables, fetching some values from the tables, or other operations of this kind. Well, you may have guessed the solution. Here we need a specialized database language to perform these operations on the objects inside the database, such as the table. For example, if you are working in the SQL Server environment, you will know that the specialized language to do so is T-SQL in this environment. All right, we will make a conclusion up to here and then discuss the SSAS concepts. Okay. So far, we said that we need a database that does not do anything on its own. To better understand this concept, we said that you could consider it as a box containing the personal items of each individual. Inside this database, we create some tables that are in charge of storing the data. Eventually, we need to work with the T-SQL language when we want to perform some tasks in these tables, such as recording, deleting, recovering, or updating the data. This world of data that we talked about so far is called the OLTP world. So, this is the OLTP world, which is our point of entry for analysis. What does that mean? It means that the data we collect from the customer in projects to perform analysis on are usually OLTP data collected over the years. Now we receive these data from a specific customer and implement the analysis using analytical tools such as SSAS based on them. You might have a question now. Are the data delivered to me as input for the analysis always this kind of data? The answer is definitely no. There might even be a business that has obtained the data from these sources and stored them in a data warehouse and is now asking you to conduct an analysis of these data. Do you know what is good about this kind of data? That they are almost cleaned and ready. You know that when we are talking about data warehouse, it means we have practically passed the OLTP data through some filters, cleaned them based on some parameters, and have brought and stored the cleaned results in another database and another place. Well, this data is much more valuable to work with rather than the OLTP data from the beginning. But I must say that most of the works available are OLTP, a large portion of which are dirty and require you to do the cleaning in the beginning. You will figure out later that in an analytical project, the greatest time has to be devoted to this part, which is cleaning the data. If you enter dirty data into the analysis stage without cleaning them, you will definitely get an unfavorable output regardless of how professionally you have done the rest of the job. You know what they say, garbage in, garbage out. So, let's draw a conclusion on what we discussed in this section. The input data are the OLTP sources of the customer collected over the years on which they want to perform analysis to learn about the current state or make predictions about the future. Then we discussed whether these data are always the base for our work. Our answer was no, that data might be saved by the customer in a data warehouse, And we said that what is good about the warehouse is that the data has already passed through some filters and gotten cleaned, so our work here gets easier, and we will have a more accurate final output. And if the data do not exist in the data warehouse before and our initial data, OLTP, we will have to do the cleaning ourselves.